Welcome to Programming in Modern C++. We are in week 11 and we are going to discuss M54, module 54. In the last module, we have talked about different techniques using or without using std::: function to write and use non-recursive as well as recursive lambda expressions in C++ 11 and 14. We have learnt about generic lambdas, we have learnt about generic capture, and we have left with several practice examples that you should try and test out. With that, actually the general features of C++ 11 we have now completed discussing, and in the current module we will discuss a set of features which are related to the class. Class we learnt about different things about the class, data members, member functions, constructor, destructor, all of that, inheritance, all those. So the whole bunch of things that apply to classes, these features are extensions on those, modifications on those, and unlike say Rvalue semantics, Rvalue reference and move semantics, or like lambda, which are big single feature of enhancement in C++ 11. These features are small features which kind of are standalone, but helps to enhance the object orientation in several ways. It facilitates better generic programming, it improves readability. Some features are just given to improve the readability. Some features improve the type safety, some improve the performance and mix of those. So you will not see a very coherent discussion on examples of all of these features being used in the same place, but once you get comfortable with them in the subsequent module, you will see different of these being used at different places. So here is the module outline, and let us get started with the first, which is default and deleted functions. In C++ 03, in module 25, if you recall, we had discussed a problem that if I want to create a class where copy is not allowed, copy will not be allowed. We saw the solution was to put the copy constructor and copy assignment operator as private, or to have a base class something like uncopyable, non-copyable, where these are private, and then you privately inherit from those and so on. You should recap on those slides before you proceed further here. In C++ 11 delete feature, equal to delete function feature, all that you can do is you can simply write the signature of the function and put equal to delete, which means this function will be known to the compiler, but the function will not be provided by the compiler. This function cannot be used. As simple. Delete says this function is prohibited to be used. This function is a member of the class. This function will be used to resolve overloading and all that. It is as if it exists in every possible way, but it is not, it cannot be used. Similar or kind of not similar, but maybe the other end of the spectrum is, you can say that explicitly say that some function is default. So what we know that if copies are done for the objects of a class and no copy constructor is provided, the compiler provides one. Now copy constructor can be provided with constant reference, with non-constant reference, or other kind of things. But what you want to say here is, you are saying that this is the signature, the copy constructor must be there, point number one. This is the signature, and the compiler should provide a default copy semantics. Right? It is not necessary that if you provide copy constructor as default, you will have to make copy assignment also as default, but whatever you make default, the compiler will provide that, and everybody. So the advantage here is it improves the readability also, and improves the resolvability also, right? Because, for example, you might wanted that you want a default copy constructor which does not use a constant reference because of some reason, whatever. So if you want to do that, you can provide it here and say default. The compiler will still provide it, but the signature would be as you have provided. So actually this default mechanism, delete mechanism, is not limited to just constructors or copy or operations. This default mechanism, it can be used for any function that has a default. It can be used for move as well. And delete is possible for any function to eliminate something that you do not want. For example, say you have a structure z class z and you have a constructor from long. Now naturally, if you pass a long value to it, this object will get constructed. But suppose you would specifically want that you will not allow long values, you necessarily want a long value, then what you can do, you can simply say that z long is equal to delete, which is that the constructor taking long as a parameter is a valid member function of this class, but you are not allowed to use it, right? So this is the basic idea of the default and delete. So we know all the different functions which are available for default constructor, destructor, copy constructor, move, copy operations, move operations, and there are restrictions for them. But when you get the default from the compiler, you get them in this kind of form, that the default version is always public, it is always inline, and it is always non-explicit. Right? By using the default option now, you can change those as well, as we'll see. So here are examples of default member functions. We are saying this is a copy constructor, that if we provide that, then the default constructor will not be provided, move operations will not be provided. And then you say that there is a declare, this is your default constructor, which should use a default implementation of the provided by the compiler. Similarly, this is a move constructor, for which default should be given. But most importantly, what you can do, you can change the behavior of the default. For example, as I said, the default is public, right? What you are doing here, you are declaring a move assignment operator in private and calling it default. So the compiler will still provide the default, but it will not make it public, it will make it private. Similarly here, compiler gives constructors, copy constructors, which are all non-explicit, but we are saying that explicit this is default, right? So the compiler will still provide that, but it will be an explicit constructor, which means that implicit conversions cannot be done with it. So this is similarly, you have made the destructor virtual and so on. So these are the advantages of default, and in delete you can similarly do all this. Delete for preventing copying or suppressing implicit move operations and so on. Right? You can see these examples. So here is an example of delete. So here I have this void star, f takes void star, and it takes f takes const cat star, which I have deleted. Now with this, it does not mean that this function does not exist. It says that the function is defined but deleted, which means that you cannot use it, but it will play a role in overload resolution. So there are actually two overloaded functions here, and I have here two variables p1 and p2 of two different pointer types. You call this by P1, it binds with first overload, so it is fine. But if you call it by P2, then it tries to bind with the second one, and since it tries to bind with second one and f const star is unavailable, this becomes an error. Similarly, if you pass it as a const cat star pointer directly, it tries to bind here and will be an error. But if you give it like this u here says that it is a unsigned, it is a 16 Unicode character string, 16-bit character string. So it is, so this is not same as cat star. So this will not bind here, rather this will bind here and it will be allowed to use this, right. So these are the different ways that the delete can play a significant role in this. So having seen this delete and default feature, let's see how do we really control the default move and copy that the compiler provides us with. Recall in module 51, we have had a discussion on move is an optimization of copy, which means that it needs the move and copy operations and the destructor, because move and copy are for resources. So if there are resources, destruction is required. So two move operations, construction and assignment, two copy operations, construction and assignment, and the delete operation, these 5 have to be defined in a consistent semantics, right. Therefore, the compiler has to decide what it should provide, and you have to decide how you should ask for them. So let's consider that for each one of these 5 functions that I mentioned, 2 move operations, 2 copy operations, and the destructor and the destruction, there are 5 possibilities each. One is nothing is said about a function, it's undeclared. One is the function signature is given and defaulted. One is it is declared that you have written this but not defaulted, just ended with semicolon. One is you have given the signature and said deleted, and one is you have given the signature as well as you have defined. So naturally, if it's undeclared, then it is implicitly default. If it is equal to default, then it is explicitly default. Its signature is given and that the compiler has to provide. If it is declared but not defined, then the use is prohibited, but you will have a linker error, right, because it is defined, declared but not defined. If it is deleted, then you will not have a linker error because you will not be able to compile it even, right. So the prohibition of use have two different semantics, and if it is defined, then it's a proper use. So this brings us to 5 times the 5, 25 possibilities, 25 possible semantic scenarios could be there. Right? Each one of the 5 functions, for each one of the 5 functions, I can do any one of the 5 options. But these 25 scenarios are not meaningful because they are not consistent semantically. So to keep them consistent semantically, the compilers have to follow a set of rules, and as a user, as a programmer, you have to follow a set of guidelines. So the rules compiler follow are into 2 groups. One is called the move rules. Move rules say that if any move, copy or destructor is explicitly specified, then no move is generated by default. Right? If any one of these is explicitly specified, then nothing is. So explicitly specified means that it is either declared, or it is defined, or it is defaulted, or it is deleted, any one of these. So no move is, if it is declared but undefined, it is a linker error. If it is defaulted, then it's a move is a compiler default. If it is deleted, then it's a compilation error. If it's undeclared, then it defaults to the corresponding copy operation. If you have not said anything about the move, it will take it to be the corresponding move copy operation. Here is an example which you can study for yourself. Copy rules are somewhat different because copy rules existed from before. So, in copy rules it is selective, that out of the two copy operations, if you provide one and do not provide the other but use it, whatever you have not provided will still be provided by the compiler. Move is not like that. You provide any of the move operation, copy operation, destruction, all other will not be provided default for. Right? So, any undeclared copy operation is generated by default. So, you can see the copy rules for the default copy rules for the compiler is different. Right? If any move is explicitly specified, then no copy is generated by default. Right? So, you should have expected the rules to be symmetric, to be similar, but that is not the case, because the default copy rules in C++ 03 is a legacy which has to exist as C++ 11 goes forward. Right? So, here there could be some, because of this default copy you could have some very nasty problems which are very easy to create, that you have a class X which has a pointer which you have dynamically created something, and therefore your destructor has a delete. It is very logical. Right? Now, you have not provided a constructor, you have not provided a copy constructor, you have not said anything, which is a C++ 03 scenario. So, what will happen? If I write x1, a default construction will happen, and then say you have done operations to set this something to this p, it is pointing somewhere. Then you do x2 by a copy of x1. So, the default copy constructor will be invoked, and default copy constructor will do a shallow copy. It will just copy the pointer, not the pointed object. So, two pointers from x1 and from x2 will point to the same object. Now, what will happen? As you come to the end of the scope, both of these are automatic objects. So, according to lifetime rules, on both of them the destructor will be invoked. So, first you will have the destruction on x2, right. So, that will delete p, that object is gone, pointed object is gone, but then you will have the destruction for x1. So, it will again try to delete on the same pointer because the pointer has been copied, and you will get a double deletion error. For example, if you try on that online GDB compiler, this is the error that you will get. Right? So, these are problems which exist in C++ 03, and C++ 11 has not been able to address this. But so far as the mix of move and copy is concerned, it has tried to do a decent job. Now, given all this, it also is there are a set of guidelines that have been provided as to how you use these defaulted functions. So, three guidelines. One is called the rule of 0, that try to avoid defining default operations if you can. That is the best thing. You take responsibility of everything. Or the rule of 5, which says that if you define any in terms of declaration, delete, any copy, move or destructor function, then do that for all. Right. So, rule of 0 and rule of 5 are the basic thumb rules for using, and there are some more details which you can see. These are drafted by none other than Jernej, Stroustrup and Herb Sutter. So, you should follow that to make sure that you have a consistent default move and copy semantics. Out of the 25 possibilities, only a few will be meaningful, and you should stick to them. Otherwise, you will have the kind of surprise that I just showed you. Okay. Moving on, we will take a number of small features. Delegating constructor is something very interesting. This is something, if you have a class with multiple constructors, it is often that there is code copies. So, there is a widget class and there are 4 constructors, a default one, a copy one and 2 parameterized one, and these 4 are written here, and the red codes you can see are basically repeated code. The whole idea is to show that multiple constructors often share the same initializing code. So, for that in C++03 what we do, we write different init functions and try to call the init function because of that, and cumbersome hand-woven techniques. Here in C++11 you have a very nice feature. From one constructor you can call another constructor. From one constructor you can call another constructor. So, by that you can make things much simpler. For example, what we notice is that here registering object is something which looks to be pretty repetitive. Constructing the base class with certain call to certain function is repetitive. So, we define a constructor which as it is not amongst these four, a constructor with int and double. There is none such in this list, and to make sure that this constructor is not directly used, we make it private. Where we do this base calc, setting the size that is the int, setting the floating value and registering. Then what we do for using, say, this explicit constructor, we set a default value to int and let that, see this carefully, this is the constructor and it is calling this constructor. This is the constructor, it is calling this constructor, a feature which we have not seen before because it did not exist. So, what it is doing is one constructor is delegating its responsibility to another. So, here for the default constructor it does something interesting. It delegates to a constructor which has a default double value, calls 2. 2 in turn delegates it to the private constructor here. So, double delegation. So, delegate T can also delegate further, and you can see that with that, in contrast to all that you had here, you have a small code, very readable, very manageable, and you cannot, for example, in writing this somewhere you could miss out this, but here you cannot do that. But there may be exceptions to that as well. For example, the copy constructor did not fit into that model because it does something different. So, we do not touch it, we are not doing any delegation in that at all. Right. So, this is the notion of delegating constructors, and delegator and delegatee may each be inline, explicit, public, protected, private, all of those. And if you delegate, naturally the delegated construction is done first and then the delegator will be done. Second feature, very important in terms of ease of use, is in-class member initializer. In C++03, we had static members, non-static members. Static members could be initialized within the class provided it is a constant member, it is of integral type, and you are using a constant expression to initialize it. Otherwise, you have to write the static member there, and outside the class you have to again write and put the initialization, declare that variable and define its initializing value, which often you have questioned really as to how useful it is or how convenient it is. So, if you look at C++03, this is what is permitted. All of these are errors, because this is not static, this is not a constant, this is not using a constant expression, and this is not of integral type. In C++11, all these have been relaxed, and further actually non-static members can also be initialized in the class. So, In C++03, if you have a variable non-static data member A, and in the constructor you will put this initialization. Here you can just with int A you can say initialize with 7. So, this is a great advantage because you may have multiple constructors, as we have just seen in the delegating constructor, which initialize. You can have multiple constructors, as we have just seen in the delegating constructor case, that initialize the same data member with the same value. So, here is an example of a class where each of these 3 constructors initialize with the same value. Right? It is difficult to write it repeatedly without making mistake and lot of code messes. Instead, what you can now do is you can write it simply along with the data member declaration, that H_algo has an initial value which is within quotes MD5 and so on. So, what will happen in the constructor, once you write this in the constructor, if you are not initializing that variable or that data member will get the initialization from this in class member initialization. Now, here, so these were taken care of. So, all that I am left with is A and B. And then again I see that A is 7, right? B is 5 in 2 cases, but there are cases where they are different. These are cases where they are different. Not everywhere they are same, unlike H_algo. So, what I do, I put a default initialization of 7 and 5 because they are more frequently occurring. So, with that I would not need to specify anything here. But while I define this constructor, I would not need to specify this, but I will still need to specify what is the value of A. So, now there are 2 initializations available, one which is in class member value which is 7, and one is A val which the constructor is saying. The rule is whatever the constructor says will prevail. And with that you can see this whole mess of code that you have here now becomes so simple, so readable, so maintainable and so on. So, in member initialization is a great feature to use. The next is about inheriting constructors. You know about inheriting member functions, right? And you know that a derived class will inherit the member functions of the base class, but the moment you declare a member function in the derived class by the same name, the base class member function will get hidden. So, here you have a f here double, and the moment you define it in the derived class you have f of int, then f of double is also hidden. We know that by using b::f we can make the member function of the base available here as well, right? That is inheriting explicitly from the base without being hidden. Right? So, now D has 2 f functions, but this entire thing applies only to ordinary member functions, not to the constructor. What C++11 has done, it has simply allowed that to be also be present. So, if this has 2 constructors and if I have not given any constructor here, right, then if I do say d, that is I want to do a default construction, what will happen? It will do the construction by the default constructor of the base. This is fine. Now, suppose I have not provided this, but I have provided this. Okay. So, what will it do? It will hide the default constructor of D. Right? It will hide the default constructor of D. and it will say that there is no constructor, and because there is only one constructor given. So, this problem was not directly solvable in C++03. So, now what you can do? You can say using B::F. So, which means that these two, that is a default constructor of D and a default construct and a parameterized constructor of D with int is available at this point. Then it depends on what you, how you override it, how you overload it, and that will take the effect. So, that is the inheriting of constructors. Here I have made again that principle of single slide take back. Here I have made a single slide where I show that with or without using and with different combinations of which function is available or which constructor is made available, what will be the basic effect. Try to go through each one entry for this and get comfortable with inheriting constructors. For example, if you are using this, that is, if you inherit, you have defined a constructor with string, but you are trying to do a default construction. Then it will not give you a compilation error like C++03. This, without this is a compilation error, because there is no default constructor, but here the default constructor of B will be used. But if you have provided similarly for this, say for D, here it is a parameterized construction. So, look at this, a parameterized construction. So, if you have provided something, some constructor, then you will not be able to compile this, because there is no constructor. If you inherit from B, then the constructor, parameterized constructor of B taking int will be used. If you overload that, override that in a way by providing a constructor in D of taking a parameter int and then use the base class constructor, you can see that that constructor will be used. So, this is what you gain by providing the inheriting the construction, which is what was not available in C++03. So, inherited constructors are something which is very, very important, but you have to be careful if it has, if the derived class has data members, then you may be in for surprise, because your inherited constructor obviously will not construct the data members of derived class, because inherited constructor is of the base class, right. So, you have to use proper in class member initialization to make sure that your derived class data members are properly initialized. Overrides are also given some more controls. This is something which does not add anything specific, but it is more for clarity. For example, as you inherit functions for override, like you have a function f in the base class which is virtual, and if you write it again here, you override. Here in the override feature, what you say is you explicitly say that you override. It does not do anything else. It does not give you any other functionality, but it just makes it easier to understand. For example, here just the difference in meaning you can see that here you have a function g. Here you have written this. Now in the g is virtual, so first you would tend to think that this is an override, because it is g function is, but it's actually not, because what you inherit is not g, but g which is const. But what you are writing here is a g which is non-const. Therefore, this is an overload. This is a different. This is without the const. So, if you write override, now the compiler will be able to help you on this small slip. The compiler will be able to tell you, look, this is not an override. not override, because G is not const, whereas your parent class member G is a const function. So, it will refuse to compile because of the wrong type. Right? So, these are the kind of advantages you can get by using override, but override as such this is a keyword which is a new concept being added. This is a contextual keyword, in the sense that you can still, unlike other keywords, you can still keep on using override as a variable, though it is not advisable to do that, but only when it is used at this place it behaves like a keyword. The other override control that has been added is a feature called final, which is similar to what Java has, but very different from what Java has. So, if you have a virtual function, then you can say it is final. If you do that, then any specialization of that class will not be able to override this particular virtual function. That is a simple thing. Similarly, a class can be said to be final. You can say that a class is final, then you will not be able to derive from that class. Now, it is still a lot of debate as to whether this feature has any specific value in C++, because in Java final has a different requirement, because in Java all functions are virtual, and therefore there is an overhead of calling those functions. In C++, first of all, the overhead of calling a virtual function is extremely minimal, but more importantly, C++ does have non-virtual functions. So, in Java you need to use final for those reasons. In C++ 11 or in C++, do you really need that? The debate is still going on, and after a lot of study of the recent material also, I failed to produce here a meaningful example of where final really adds value in terms of programming or semantics. So, well, know that it is there, but use it only if you are convinced for the reason. Finally, in terms of typecasting, we have seen a lot of that in module 26 and module 33. In terms of typecasting, we have seen that type can be cast by having a constructor or having a typecast operator. In terms of the constructor, we can make the constructor explicit to say that implicit conversion is not allowed. But in terms of the typecast operator, no such feature was there. So, if you convert by typecast operator, it will be implicitly, explicitly, always it will be permitted. So, this is a basic difference between if you have a f which expects the reference to a constant reference to an x object, and x as a constructor like this is the implicit instantiation, this is the explicit instantiation. Right? If this is explicit, then this will not compile. But the similar thing you cannot do in terms of the cast operator. So, if you expect an int and pass an x, either way, then in C++ 03 both of them will always compile. You cannot control that it has to be explicit. So, what you get in C++ 11 is you get to use the explicit keyword if you want in terms of the cast operator, so that you can invalidate this use. You can say that only casting will have to be only explicit. So, that is the semantics that it supports. Very simple in that way to use, and a nice addition. And here are some examples of how to use that, particularly in the context of bool, where it behaves little differently. So, in this module we have discussed several class features of C++ 11 with examples that enhance the object oriented generic programming features, readability, type safety, and performance of the language. Thank you very much for the attention, and we will meet in the next module.